Today's lesson, and our objective today is to look at A3, which is making conclusions and inferences and doing analysis using the averages. So last lesson and the lesson before, we've looked at mean, median, mode, and also adding in range as well as the averages. And we looked last lesson at how to choose, so which data is appropriate for which type of average. What we're going to look at today is once you've found those averages, just a few of the basic things that you can do with them. And essentially, why are we doing this? The whole point is so that we can look at data, which is all these numbers on a page, and actually make some statements like this tells me that, I can see that, the data suggests, and all those sorts of things. First of all, just talk about what you're going to do today. So you can see, hopefully, you've looked at the Teamy post. I've got Wednesday on there. Obviously, some of you'll be doing this on Monday, depending what class you're in. So you can just see me lingering underneath. I'll just move myself down, out of the way. So here's the post you're going to do. As you can see, obviously, it's very similar to the format of last lesson. You've got a guide, a slide, and an activity. I've put a little picture here on the post to hopefully help you to see where to go, because some of us seem to be getting a bit confused last lesson. You're looking for the materials, and then Unit 6, and obviously you want the A3 activity. For today's lesson, you're going to do the work in your books, the work on a Google document, and you're going to fill in the box in the Google document, and when you're finished, you're going to put a link into your slide, so obviously I can click on that and have a look at what you did for today's lesson. So you make a copy of the Google document and then share a link in the slide, and as you can see it says just up there to do that. So we're going to go through the Teamy post, and as you can see I've got it on my iPad here, and we're just going to go through a quick example of what it is you're going to do today, and I'm going to talk you through. And don't forget, the example I'm going to go through is also in the guide, so you can read this, read it along with me, or you can kind of read it at your own leisure later. So let's jump straight in. So let's imagine we were looking at Miss Sharp's class, and they have a competition spelling with Mr. Berry's class. So they do 10 spellings, and then they record the scores. You can see Miss Sharp's class in blue, Mr. Berry's class in a kind of grey. So the question we're trying to ask is, which class is better? Now, when you first look at that data, it can be a little bit confusing. You might look at Miss Sharp's class and say, oh, look, they've got 3 people who got 10, and that's great. So they're, 4 people, sorry, who got 10. But then they also have people who got 0 and 1. So they have really, really good people, but also people who are not so great at spelling. Mr. Berry's class has some 8s, that's the highest score, but then the lowest score is only 2, and there's only 1 person who got a 2. So straight away we can see it's going to be hard without doing something to the data to be able to conclusively say which class we think is better. So what we've been doing over the last few lessons is obviously looking at averages and the range. So the first thing you should always do when you have a question like this is find those averages, and you should do all 3 types of average and the range. Now, save you having to do that, obviously, hopefully you've already kind of got to grips with that skill of finding the averages and the range. If you haven't, please go back and have a look at the previous video, the A1, which talked about how to find the averages. But if you're confident with that, we can see what the averages are. So now I've done a little table at the bottom to summarize those averages. Now, this again still gives us a bit of a mixed message. We can see, first of all, if we look at the mean, well, a higher score is better. So Miss Sharp's class on the mean average, if you just looked at that, would be the better class. They also have a higher median, but Mr. Berry's class have a higher mode, and they have a lower range. So we've got 2 things which Miss Sharp's class is better for, and 2 things that Mr. Berry's class is better for. So that leaves us with a little bit of a dilemma. So we've got to do a bit more thinking about it, what each of these averages means, and what does the range tell us. Now, interesting to note here that a lower range in this example is better, but a higher average. That's because the range tells us how consistent the people are. We can see Miss Sharp's class has a range of 10, which means there was 10 marks between the highest and the lowest. Obviously, somebody got 0 and somebody got 10. That tells us that they're much less consistent as a class. you might have some really, really good people, but also some people who are very, very bad. Whereas Mr. Berry's class with a lower range is more consistent. There's less of a difference between the best and the worst, which is of course good if you want to have think about any sort of team, or you don't want to have one really good person and one really bad person. You'd like to have people that are all generally pretty okay. The mean average is the only average that obviously involves a decimal, like a 2-digit decimal. Obviously, I've rounded the 2 decimal places. The median 6.5, but that's terminating. That's a nice simple 6.5 because it's exactly between 6 and 7. Whereas the mean average is kind of a bit of an abstract number, but it does involve using all of the numbers added together. The median just looks at the one in the middle. The mode just looks at the one that's the most common. So we're going to try and give some examples for each, and we'll try and look at the arguments for and against each one, and then we can hopefully make a decision. Now, the important bit is this sentence at the bottom. It says you can argue that either class is better. The most important thing, that's a terrible highlighting, is that you use the averages and the range. So that's basically what it comes down to, is you can argue sometimes, obviously depends on the data, but sometimes there isn't like a right or wrong answer. It's about how you use the averages. Now, in this example, obviously we could say the mean, we could say the median. I've used a big pen to show it's not very neat, but that's a big box and one word is not sufficient for what we're looking for. We need to say what each of these things means. Why is the mean being higher? What does better? What does that tell us about the data? Why is the modal average being higher tell us about the data? And how can we use that to start to construct an argument? And I'm just going to finally go to the last part where we talk a little bit about them. So first of all, we can see that for Miss Sharp's class, the mean average is higher. It's about 0.32 higher. Now, when you think about that as a number, 0.32, that's just around a third of a spelling. So you're saying on average they're about a third of a spelling better. But what you've got to think about is it possible to have a third of a spelling? However, what that also tells us is if the mean average is higher, that also tells us the combined score when we add them all together is higher. If Miss Sharp's class was doing it, one big test and they were all putting their scores together, they'd have got 135. Mr. Berry's only got 132. It's quite close, but Miss Sharp's class did score more correct spellings all together, which is important. Now, when you think about it, the second point, the median, that's 1.5 spellings higher, which is quite, out of 10, that's quite a big margin. That also tells us, because the median splits the data in half, that tells us that the top half of the data for Miss Sharp's class is higher than the top half of Mr. Berry's class, in that from halfway onwards, people are scoring 7, 8, 9, or 10. So half the students scored 7, 8, 9, or 10 in Miss Sharp's class. Whereas in Mr. Berry's class, we can only say that half the students scored 5 or more, which is a big difference. Mr. Berry's class, what's good about them? Well, they've got a modal average of 8. 7 of the students scored 8 altogether. That's quite a large amount of students. When you count up the number of students, there's around 20 students, and so you're saying around a third of them scored 8 points, which is a really, really good score. And like we talked about earlier, the range is lower, which indicates maybe in Miss Sharp's class, it's not the whole class that's perhaps very good, but maybe just those who are scoring 10 are kind of pulling the average right up. But there's only 5 of those who are scoring 10. So that's, maybe it's just those 4 students that are really good and the rest are kind of lagging behind. Oh, I'll just save that. Not sure what that was. I think that was somebody sending me pictures. Yes, okay. Okay. No, don't open them. Okay. No. Okay, I'll have to edit that out in a minute. So, where was I? Right. Back to what we were saying. So, we have arguments for both sides for why each class was better. It doesn't really matter which one you choose. I'd probably say on balance, Miss Sharp's class might be a little bit better because of the median telling us that half the students were 7 marks or higher, which I think is a pretty important fact. But you could again argue that it's only those 4 tens that are dragging their score up, which is why the mean average is higher. Maybe if you take the top 4 of each off, that would be different. There's lots of different things you can do. The most important thing in your answer is not what you say, but how you say it. Have you used the mean, the median, the mode, and the range to justify your answer? So you're going to have a go at that with a few questions. There's 5 of them to do in the Google document. All you have to remember each time is find the averages and how can you use them to tell you about the question. And it might be about better or worse, higher or lower. It depends on the question. But just think, what does the data tell you? Is higher or lower better? And how do the averages and the range support that argument? Low range is consistent, high range is inconsistent. So have a go at the Google document and I will be on the Google Meet to help you if you need it.